Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions for AP Physics 1 exam. In the last few videos, we have discussed from question 1 to question 45. And today's lesson, we will start from question 46 and we will discuss all remaining questions from this paper. As always we will discuss these questions in detail so you can improve your conceptual understanding of these concepts and also you can have better understanding of these questions. Let's study together, let's improve together. Question 46 says a uniform plank is placed with a pivot at its center. A block is placed on the plank to the left of the pivot as shown in the figure above. A student is asked to place a second block of greater mass on the plank so it will balance when horizontal. Which of the following quantities are needed to determine where the second block should be placed? Select two answers. So in this case simply we have to balance this block and we need to select two answers. We can imagine the mass of this block, let's say, is capital M and the mass of this block is small m. In order to balance this block, we have to place this greater mass closer to the pivot. So it has to be here. For this purpose, simply we need to understand equilibrium. So we can write down in equilibrium. So when this block is in equilibrium, clockwise moment. So we can say moment clockwise moment has to be equal to anti-clockwise moment. These two moments has to be equal anti-clockwise moment. So we can say CCW, counter-clockwise moment. Due to this block, moment will be clockwise, so this will be CW, clockwise, and due to this one it will be anti-clockwise, CCW, and these two moments has to be equal. Clockwise moment we have, this is capital M, G, and the distance from the pivot. So we can say this distance is D1, and we can say this distance from the pivot, let's say this is D2 times D1. This one has to be equal to small mg times D2. So we need to consider in this case two things we have to consider. So G will be cancelled. So we have to consider in this case mass of each block to balance this block. Mass of each block we have to consider, means we have to consider this mass, we also have to consider this mass of each block we have to consider, and also we have to consider the distance from the pivot, distance of each block from the pivot. Distance, actually proper way to say this one, perpendicular distance. So this is perpendicular distance of each block from pivot. So these 2 points we have to consider. Now if you look at given options, it is given to us mass of the plank. Mass of the plank doesn't matter. It is lighter, it is heavier, it doesn't matter, because this is uniform plank and its center is placed at the pivot, so its mass doesn't matter. Mass of each block we have to consider. Yes, this option is correct. The length of the plank doesn't matter, so this option is incorrect. The distance from the pivot to the left block, yes, we have to consider, so this one is correct. So answer is B and D. Two options we have to choose from the given option, so the answer is B and D. Question 47 says a block is held at rest against a wall by a force of magnitude capital F exerted at an angle theta from the horizontal as shown in the figure above. Let F sub G be the gravitational force exerted by Earth on the block. Fn be the normal force exerted by the wall on the block, and F sub F be the frictional force exerted by the wall on the block. Which of the following statements about the magnitudes of the forces on the block must be true. Select two answers. We have to select two answers. And this question is simply about forces. The forces acting on the block. One force is given to us, capital F. This force is acting on the block. And we can resolve this force into its two components. So one component is acting vertically upwards and one is acting to the right. So this has two components. And this component of the force, we can say upward, this has to be F sine of theta, because this is opposite to the angle. And with angle, this component has to be F cosine of theta. We can also draw the force of gravity that is acting on the block. We can say this one is Fg. And the normal reaction force acting on the block by the wall. This force is pushing the block with this force to the right, and the block will push the wall with the same force, and the wall will push the block to the left. So there is a force on the block by the wall, and this is Fn. And the frictional force can be upwards, frictional force can be downwards. If the block has tendency to go up, frictional force will be down. If block has tendency to go down, friction force will be up. So frictional force we can simply write down. It can be up or it can be down. So simply we can write down this is plus minus F. So if we look at forces along horizontal, so we can say along horizontal. So simply we can say along horizontal. So there are two forces. So in this case simply we can say Fn has to be equal to F cosine of theta. These two forces has to balance each other, so the block will not move horizontally. And we can also resolve forces along vertical. So along vertical we have Fg, this is acting down. F sine of theta, this is acting up. So we have F sine of theta, this is acting up, and this one has to be equal to Fg plus minus force of friction. If block has tendency to go up, friction will be down. If block has tendency to go down, friction will be up. So it depends on which way block has tendency to move. So this is how forces are balanced along vertical, and this is how forces are balanced along horizontal. If we have understanding of these points, now we can choose the answer. If you look at first one, it is given to us F is equal to Fg sine theta. So this is telling us that Fg is equal to F sine of theta, but it is missing the frictional force. This part is missing, so this one is incorrect. F cosine of theta is equal to Fn. Yes, F cosine theta is equal to Fn. So this one is correct. This option is correct. F sine of theta is equal to Fg plus minus F. This is. So C is also correct. And D is incorrect. So this is incorrect. So the answer for this question is B and C. We have to select two answers. So this is the answer. Beautiful question on forces. Question 48 says some students have determined the gravitational mass of an object and want to compare it to the object's inertial mass. Procedures that would allow them to accomplish this include which of the following? Select two answers. Which procedures can be used to determine inertial mass of the object? If you look at option A, it is given to us hanging the object vertically from a spring scale and recording the scale reading. First of all, this is depending on gravitational field, and this will give us gravitational mass. So this is depending on gravitational field, and in this case we will get gravitational mass. So this option is incorrect. If you look at option B, it is given to us placing the object on one side of a double band balance, adding objects of non-masses to the other side until the masses are balanced, and recording the amount of mass added. This also depends on gravitational field, and it will help us to find the gravitational mass, because it is relying on gravitational field and it will give us gravitational mass. So option B is also incorrect. Now if you look at option C, it is given to us attaching the object to a spring of non-spring constant, allowing it to oscillate horizontally on a nearly frictionless surface and measure the period. So in this case we can determine the period, and spring is oscillating on a horizontal frictionless surface. So it is oscillating, mass is oscillating on horizontal frictionless surface. So in this case we can determine the time period. Time period T will be equal to 2 pi m over k. So if we have time period and if we have the k, we can find the inertial mass. So this option is correct. So we can determine inertial mass. Now if you look at option D, so this one is correct. Attaching the object to a force sensor, using the sensor to pull the object across a nearly frictionless horizontal surface. So pulling the mass. So this is telling us we have mass, we attach with this one object to a force sensor. So we attach object to a force sensor. Simply we can imagine this one is the force sensor and this is on frictionless horizontal surface. So we can determine in this case the inertial mass and measuring the acceleration. So in this case this is not depending on gravitational field. So this is not relying on gravitational field, so in this case what we will get, the mass we will get, that will be the inertial mass. So we can determine inertial mass using these two methods, C and D. So the answer for this question is C and D, inertial mass. Question 49 says the figure above shows a representation of a wave traveling in a uniform medium at a particular instant. Correct statements about the wave include which of the following? Select two answers. So in this case we have to select two answers which are correct about the given wave. If you look at this given wave, we can see the particles here. Particles are very close to each other, so we call this region is compression. And if you look at the next region, here we can see particles are far away from each other, we call this is rarefaction. So here again we have compression, here we have rarefaction, here we have compression. And this wave, a wave which consists of compressions and rarefaction, we call is a longitudinal wave. So this wave is longitudinal wave. So simply we can say this is longitudinal wave. So this is longitudinal wave, and the distance between two consecutive compressions or rarefactions is equal to one wavelength. So A is the distance between two consecutive compressions, so A is equal to lambda. Now if you look at given options, if you look at option A, it is given to us it is a longitudinal wave. Yes, this is correct. So this is longitudinal wave. Distance A is the wavelength. Yes, this is correct. The number of dots per unit length is the frequency. This is incorrect. Frequency is the number of cycles of a particle per unit time. Number of cycles per unit time of a particle means the number of cycles completed by a particle per unit time. That is the frequency. So this is incorrect. The largest distance between two successive dots is the amplitude. No, amplitude is the maximum displacement of a particle. Maximum is the maximum displacement of a particle from equilibrium. Maximum displacement of a particle, very important, of a particle from equilibrium. From equilibrium position, or we can say from rest. So D is also incorrect. This is the distance between two particles, largest, so this is also incorrect. So the answer for this question is A and B. Question 50 says a geologist is using a sensor to record waves in a layer of rock and is viewing them on a monitor screen. At one moment the monitor shows the signal above. If the signal is created by just two traveling waves, what can be concluded from the signal about the waves when they reach the sensor? Select two answers. So first of all, if we simply look at this given pattern, this pattern is representing beats. So these are beats, and for beats we need to understand they are produced when same type of waves traveling in the same direction, we can say same direction, slightly different frequencies, and different amplitudes. So I'm just writing it, different amplitude. When these waves they meet, they form beats. So if you understand these concepts, then simply we can figure out the answer. The waves have different frequencies, yes, so this is correct. The waves have different amplitude, yes, because amplitude is not zero. If they have the same amplitude, when they interfere destructively, resultant amplitude has to be zero. But in this case, resultant amplitude is not zero. It means they have different amplitude. So option A and B are correct. The waves are traveling in opposite directions? No. If these are beats, waves have to travel in the same direction. So this is incorrect. The waves are traveling at different speeds? No. Same type of wave in the same medium, they have the same speed. So this option is also incorrect. So the answer for this question is A and B. This question is simply about beats.